Greetings, everybody. In this lecture, I will review some of the aspects pertaining to informatics, data analytics, and data use. My name is Professor Sharifi, and I teach at DeVry University. So, our agenda for this lecture is a brief overview of these aspects. Then I will focus a little more on information systems and electronic health record highlights, and then a little bit of statistics, just very limited statistics highlights. So let's start with an overview of these aspects that are typically part of domain 4. So one of the most important domains in the RHIT exam is the one pertaining to information systems and data analytics. For this purpose, you will need to review your textbooks, Sales or John. Sales is the newer edition, and then they have chapters on electronic health records, fundamentals of electronic information systems, introduction to electronic health information systems, and information security, the electronic portions. Other material to review as far as the statistics goes is the Horton's textbook, Loretta Horton, and this is a textbook that's used in HIT 226, but any editions of it are fine. So basically in this textbook you will focus on the types of data, the various types of calculation, and of course data analysis tools. So let's start with the information systems, which I said it will be will be one of the areas to focus on. So what are information systems? Also, what is information architecture? What are databases? How about telecommunications? How about management of information systems and e-commerce or productivity software? So as you see, there is a number of different areas to look into when we talk about electronic information systems. So we're going to start with the definition of information systems. An information system is not simply a computer and a screen. It is actually a combination of input, output, the processes that go in between, the data that's entered there, the people, and communication systems. What is input? Input is the data that's entered by us in the process of doing our jobs. Sometimes this input can be entered by machines. This data can be entered by machines. Imagine the monitor that the patients are hooked up on, where you see the blood pressure or respirations and other vital signs. It could also be transferred or transmitted. It could be media, such as pictures and videos and sounds. So all of these can be considered input. And then what happens to that data? Basically, the computer system has a certain number of processes, certain types of processes that run in the background. There are software that are used, applications is another term. And then sometimes this data that has been entered is transmitted as well. The result is the output, or what we call information. Information has meaning. So data is just raw facts, and information is some sort of a report, something that makes sense. Okay, so that's what we can expect an information system to do for us. So just making sure that we understand the meaning, the complete meaning of information systems. We're talking about machines, media, which is hardware. We're talking about transmission or communication technology. We're talking about work processes, software, and the actual information. So all of these underlined components are considered part of information systems. What are the typical types of information systems? Please be mindful that these categorizations vary and they keep changing the more types of systems we see out there. But it has been agreed for the most part that there's some large categories such as the operating support systems, enterprise-wide systems, and management support information systems. In the operating support system, we have transaction processing systems and enterprise collaboration systems. In the management support, we have management information systems, decision support, executive information systems, expert systems, and knowledge management. So to give you a few examples here, transaction processing, imagine the registration area where you have patients being admitted, and then that system is able to monitor the patient's movement, where the patient is being transferred from one unit to another and then eventually being discharged. Another name for it is RADT, Register, Admit, Discharge, and Transfer. Okay, so that's a transaction processing system. In your daily life, if you were to do an analogy, consider any systems that you use to make a purchase, maybe an online purchase, or the systems that are used when you actually go to the grocery store. Okay? Enterprise-wide, let me give you an example on that. Your email, your organizational email. For example, you have the RAI email address. That would be an enterprise-wide system. If you are, let's say, part of a healthcare organization, let's say it's Holy Redeemer Health System, and you have a Holy Redeemer website, so that would be another one. Or if everybody in the organization, let's say, checks in and out by using a card or a sign in, sign off, sign in, sign out type of system to track the hours worked, that would be another example of that. In terms of management support, these are information systems that have the capability to produce reports. So remember that. If anything, anytime you hear the word or see the word management support information system, they got to have the capability to run some sort of report on the background. So the operating support doesn't always do that. You can see the detailed transaction for a particular patient, but you probably, unless there is a management support function, would not be able to see how many patients were registered for that particular day or for the week. So this is something that management support systems will do. Okay, decision support systems can be used for clinical reasons, such as the computerized physician order entry, or they can be used to make decisions on the organization, maybe adding more employees for certain units or maybe reallocating resources. The executive information systems are ones that are used by chief executive officers most of the times, and these are capable of connecting to the large data bank database of the facility of the organization, running what if scenarios. Basically, they would be able to look, let's say, into the last 5 years worth of data and looking into the trends and seeing whether there is growth or decline in a particular area, such as heart disease or maybe deliveries or whatever they're interested in looking at. Expert systems are a little different. These are systems, just as the name suggests, that provide expertise, whether it is on diagnosing patients or treating patients. Sometimes, especially in smaller hospitals, they don't have all the resources, meaning all types of specialists, and they may be faced with rare diseases. In those cases, an expert system might be consulted. Basically, a physician might enter data pertaining to the patient's symptoms and trying to figure out what are the potential diagnoses for this patient. Or they may be searching for different types of medications, newer medications, treatments that are out there. Okay? Knowledge management systems, think of libraries like the ones that are used to research, to do medical research, like the National Library, or other types of libraries that are available or resources that are available within an organization. Some hospitals might have Merck manual in there embedded, or they might have certain systems that have a medical dictionary. They have maybe some more information on pathophysiology and things like that. So let's talk a little bit more about the different types of healthcare information systems. So these are particular to healthcare. And we have them separated here in four large categories: clinical information systems, which includes anything that has to do with labs, computerized physician order entry, electronic health records, pharmacy, radiology, all of these. Some important things to remember and to review here are terms such as electronic documentation or structured versus unstructured data entry. Structured, for example, would be, let's say, age or gender or date of birth, basically where you're only allowed to enter certain types of data, okay, at a certain length. Unstructured would be maybe physician notes, just typing whatever the patient is feeling or results of a visit, so there is no limitations on how you can type the information in. Then we also have electronic document imaging, which is pretty much scanning of the paper records into the chart. Okay. Some other important terms, barcodes. You probably are familiar with the barcodes that are put in the patient's wrist. And many hospitals will also barcode medications and the charts just to make sure that they're matching everything as they are providing care. Point of care charting, along with computer on wheels, COW, that goes along mostly nursing care, where a nurse will take upon her or his assignment a computer, and then they will take that computer everywhere they see their patients. So right by the bedside, and they will document the findings there. Templates are ways to structure data entry to make it a little easier to follow through all the different fields that are needed to be collected. So rather than leaving it up to a doctor or nurse to remember to put everything, a template will actually remind them. So a template would look something less such as patient's name, and then they'd actually have to put in the patient name or maybe select it from their EHR screen or whatever the system provides them with. Or and then next to it maybe diagnosis, and then they would just populate the diagnosis, and then findings, and they would go in and type the findings. So basically, there's sections of the document that these clinicians have to fill out, and most of them are actually mandatory, and some might not be. So it depends on how the template is designed. Moving on to administrative information systems. These can be financial systems, human resources, systems that are used to manage facilities, materials, inventory, all of these. Then there is management information systems. As I mentioned earlier, anything that has to do with reports goes right into management. Okay. Um, there are different types of reports. There's those that are periodic or scheduled, where every Monday morning we need to have, let's say, a discharge list, or every once a week on a certain day we need an exception, we need a certain report on bills or something like that. And then there's exception reports. Exception reports mean that you have certain rules built in the system that allow you to create a report if something falls out. Let's say a report of all unpaid bills. Okay? A demand report is one that you request. Maybe you want to do research, or you're helping a physician with a research, and they say, I want a report of all the patients that were admitted between this date and that date that had this particular diagnosis. There's also strategic decision support and executive information systems. So I addressed these in the prior slide just a little bit. So basically, any systems that will help manage the management team make decisions moving on to the future and deciding how to allocate their resources, or run what if scenarios, as is the case with executive information systems. The last category is research and data analytics systems. So these are systems that are used to do data analysis. First of all, we would need a data warehouse, which is a huge um, database of databases, if you will. So envision a hospital that has, of course, an EHR. It has a lab system that has transcription system where you have all the transcribed reports. Maybe they have the radiology with all the images, picture archiving, communication system, all of those things. And now you're digging into that data, which is data mining. So data mining is digging. And then you're trying to figure out if there are any trends, if something is out of the ordinary. Let's say, are you seeing a much larger number of patients with pneumonia this year than the prior year? Or are you seeing an increase in the use of, let's say, antibiotics or painkillers or whatever the case might be? A difference between a data warehouse and a data mart is literally in the size and what types of databases it hosts. So data warehouse is larger, and you can host all types of data there, all types of databases. A data mart is smaller, and usually it's specific to a set of data sets. It could be, let's say, just for the lab portion, or another type, whatever, depending on the service that the organization provides. When we talk about information systems, it's important to understand their cycle. What is their cycle? How they're developed, how they're implemented, and then how we continue to keep up with them and you continue to use them. This involves a process that has different stages. For now, they have identified 5 stages, but then again, you have to be mindful of this depending on where you work. They might, in some places, they combine, let's say, planning and analysis together, and they come up with 4 phases. In some others, they might even break up maintenance and then evaluation and maybe create 6 stages. So the exact number of stages is not that important, but what is important is the order in which these things happen. So basically, it starts with an identification of the needs, which is the planning. What do we need? Okay, or what is required. Maybe there is something that we need to do for compliance reasons. Or what is wanted. We want to do something that the other hospitals are not doing because we want a competitive edge. And then we also consider the costs, how much money we have. Do we have a good timing for this? How long is it going to take to approve it? Things like that. And then we go into the analysis phase. Basically, this is where we address all the details about the system. What is this system going to do? What will be impacted? What else is needed? This can happen by working with a team of computer programmers and developing a joint application, okay, so, which is a joint application development process. And in that case, you would have to document all the requirements and explain to them how everybody is going to use the system, whoever is planned to be part of that system. What is the sequence or the order in which steps are taken. For example, when you're ordering a medication by using a computerized physician order entry, what's the sequence there? The physician puts in the name of the medication, the dose, the route, and then from there, where does it go? Does it go to the pharmacy? Okay, yes. So from the pharmacy, what happens there and where does it go from there? So this would be an example of sequence. Okay, and programmers, computer programmers, put those into diagrams so they can understand what's going on and how to um, actually design this. Use case has to do with identifying how different parties are going to use it. Obviously, a physician is going to use a system different from a coder or a nurse. So that's what the team, the programmers, need to know in this process. In this process, when they're documenting everything, they use what we call a Unified Modeling Language, UML. You don't need to know much about this because you're not in a programming school or anything like that, but just understand that it is a language that allows different computer programmers to communicate with each other by basically using this unique modeling, this unified modeling language. Okay, just a bunch of symbols. Okay, the next phase would be design. So either you're going to go into design and you let the programmers write the program and you look at the screen prototypes, or you don't do it in house, but you decide you're going to go with a vendor. In that case, you do a request for proposal. Basically, you ask a number of vendors out there, do you do, let's say, do you design or do you have a coding system? If you do, how does it work? What are the functions? What are the features? And then they provide their information. Then you can go sort through it and see which one you like the best. And then usually you bring them in for a demo, a demonstration. And then you pick, as a team, which system seems to be the best. There is an evaluation system based on this request for proposal. And you might value maybe the reliability of the vendor, or you might value the way they have designed the system. It's easy to use. Or you might value the fact that, well, most of the other facilities like ours have adopted that one, and they're doing well, so we'll go with that one. So there's different criteria you can use, or sets of criteria. Once that has been decided, then you go into the implementation phase. During the implementation, everything is developed in the computer programs. There is testing of the system. A lot of testing is going on just to see how, let's say, if it's a new coding system, are you able to connect to the patient's record? Are you able to actually search a code or for diagnosis or for procedures? Are you able to transfer the information from, let's say, coding to billing and so on? And then there's a lot of documentation about the system, how it's going to be used, the steps or the different scenarios, training. The users are going to be trained either in groups or all together. And then the actual conversion happens. Conversion is the movement from the old system or no system to this new system. And it can happen in multiple ways. It can happen in a parallel format. Basically, you could have the old system and the new system running for a week or so, just to make sure that they're both giving you the same results. It is time consuming, labor intense. It's not used that much, but it can be used if there was not enough testing, just to make sure that the new system is not letting you down. The phased approach is a little different, and it allows you to implement the new system in one unit or in one department. And you see how it goes there. If there's any glitches, you fix them, then you expand into two or three more departments. And then from there, you go live into to the entire organization. And this is a little popular because it allows people to take some time to fixing any bugs or glitches with the system by at the same time not affecting everybody in the organization. And the third one is a direct cut over approach, meaning you go live everywhere. The entire hospital or the entire organization will stop using the new system and will start using the will stop the old one and will start using the new system at a specific date and time. With a lot of testing, this can be very successful and it's very popular. The last stage is maintenance and evaluation. It's a stage when a lot of backup is done, updates on the systems, upgrades, and any other maintenance. There's new users perhaps that need to be trained or assistance for the other ones. So this is in a nutshell the systems development life cycle, and there is a lot more detail about it in your textbook. So a little bit about information architecture. What I this sometimes throws people off, and it's not that difficult because we're not getting into the details of it. All you need to know really is to understand the concept of it. What is it? For this reason, I put this picture here of the buildings and the street. Just like in a city, we have a system of naming streets, naming the buildings with numbers and you know names, all of that. That's how the information architecture is. It has to do with the organization and labeling of websites, intranets, online communities, or software to support the ease of use, just to make sure that we know, let's say, where the information was taken from or where to transfer the information. This is the only way the healthcare organizations will work, let's say, with providers, with insurance companies or payers. If you don't know exactly where you're sending the information, then how can you send it and still be compliant with privacy and security measures? So it is a very important aspect. Just understanding the basics of it will be sufficient. Let's talk about computers a little bit. There's different types of computers, all the way from supercomputers, which are very, very large, even as large as like a room size, the size of a room, all the way down to cellular phones, which are obviously small. What do we see mostly? We do see a lot of microcomputers, handheld devices, and cellular phones for everyday use and in the hospital, and they use in the hospital, ambulatory care facilities. However, what you don't see is probably the mainframe or the mid-range systems which are used in the back end, in that IT room where they're backing up everything. Okay? You don't see much of a, in terms of supercomputers, you would not see much of that in healthcare. Um, maybe when for the group that actually worked on um, that that may be working on genetic stuff. There is tons of data there, so they might need superpowers there. For the most part, these are used for the weather predictions because they're large enough to calculate a lot of data per minute. Okay. Computers that we use now are digital, but at one point they were analog. And as far as the peripherals go, there is the input devices, which is your keyboard, your mouse, sometimes even the screen if it's a touch screen. Output devices, which can be a printer, a screen where you see the information. Data storage devices, which is a server, a USB drive, a CD, which are not really used that much anymore. Processors, basically, these run inside the machine. You don't see them, but they are there. If you ever have an old computer, you want to open it up and look it up, by all means do that. And then, of course, the communication devices, whether it is your router, your modem, or whatever you're using to communicate or to connect to the internet. So let's talk about the computer languages and software. These are languages, or yeah, languages are used to actually communicate to the machine. So how does the machine know what we are inputting and how to give us the certain feedback? There's a language for that. Initially, it was just the machine language. Basically, everything that was communicated was a combination of zeros and ones. And then we evolved into assembly languages, which was a list of approved abbreviations that could be used to communicate with a computer. And then we moved into high level languages, which was words and arithmetic phrases. So basically, you could say run, which is a word, and then let's say you wanted a report of patients that were admitted with a certain disease, but um, not that other disease, or this disease and that disease. So basically, you would formulate a sentence that say run, and then however you stored the patient information, maybe PT for patient, because there's abbreviations there as well, plus with CHF, let's say plus PN for pneumonia, just as an example. You don't see that much today. You probably see mostly very high languages, which basically shows you it's very user friendly. You have a lot of options on your screen, and you can just click and drag. That's what the structured query language is, SQL, or there is another one, SPSS, which is for statistics. So you see what you are including in your report, or you see what you want to enter into a particular screen. And then there is natural languages, which is verbal, the way you talk to your phone, like Siri, find me this, or take me there, or what is that, or whatever. You ask your telephone, and that's the way you communicate with your phone. When it comes to software, there is system software, meaning the ones that help the computer operate, the operating software, or the utility program. We're not going to do much there. And then there is the computer programming software, the language translator. So we just talk about programming languages. Then those zeros and ones, or those arithmetic phrases, or SQLs, or whatever we have there, they need to be translated so we can understand the information. That's what the computer programming software is about. And the third one, and this is actually the one we're going to work mostly with, and you already do, is application software. Anywhere from Microsoft Word, or Microsoft PowerPoint, or WebEx session, or registration system. So those are all application software. All right, so let's talk about databases. What are databases? They are actually the backbone of information systems. That's where the information goes, okay? They're organized collection of data on a computer, and they can be relational, meaning just tables, rows, and columns. They can be object oriented, which is just a bunch of objects, such as, let's say, iTunes or YouTube videos, or object relational, where you have a combination of tables, where you have those rows and columns, but also objects inserted. And often we find those in healthcare because we might have a lot of information on the patient that is stored in a relational database. However, we might have images from the radiology, we might have sounds from the uh, ultrasound department, so all of those are going perhaps into one record. Okay, and what do we use the databases for? To store data, to retrieve data, and of course to provide a certain level of security. Okay, so that's a must for the database. So let's look at a quick example here. Like I said, they're made up of rows and columns. A row would be, let's say, the first one. Medical record number is 23546. The name is Jane Smith. Date of birth, January 16th, 1976. Data value, actually columns. Columns would be first name. So if you wanted to run a report by first name, or maybe just date of birth, or if you had more age or zip code, whatever you might have, then you can do that by column. Data values are what you see in each cell. So Doe is a data value. March 4th, 1967 is a data value. 21405 is a data value. Primary keys. These are numbers that create a unique row. So in this case, the medical record number would be a primary key, 23546. So we want to make sure for this to represent Jane Smith, whenever you type that number, it should be only associated with that patient and no other patients. That way, it becomes a primary key. Now, when we have multiple tables and they all have their own keys and we want to connect them to each other, then in that case, a primary key from another table becomes a foreign key for the one you bring it in. So let me show you a little bit more here so things can make more sense. I'm using a larger sample here, so I have more patients, and then I have more columns, I have more rows, more columns, and I have more information on each patient, anywhere from age, social security number, gender, whether they're organ donors or not, their insurance, and so on. Okay, so this is what's in the back end when you enter that information. Now, this is what you see also if you were to analyze the information. So, what is the medical record number? So, here I have all of those headings of the columns. Let me go back for a quick minute here. So, these are all the headings, right? Medical record number, last name, suffix, first name, date of birth, age, all of these. So what we have done is we have shown them differently here. So again, we have medical record number, last name, first name, age, social security number, gender, and so on. What this shows is the actual description of that data. So for the medical record number, what type of information can we put in there? It's just numbers. Or under the gender, this is the one highlighted here. So how can we report gender? In this case, it's only going to allow us to enter F or M or U, which stands for female, male, or undetermined. And it is a required piece of data. Meaning, if you're entering a new patient in the system and you're trying to skip over it, it's not going to let you. You have to fill it up. And if you are recording something different from F, M, or U, let's say you're putting in an N or maybe a D or something like that, maybe it's a mistype or misspelling or something, then it's not going to let you either because of that validation rule. So imagine when you made a purchase online, how you were trying to record something in the card number, the credit card number, and it just wouldn't take it. It only takes certain things. If you're typing a name or letters, it's not going to take them at all. Or if you're not putting a date for the expiration date, again, it's not going to take it. This is the idea here. It's showing you what type of data will it take and what will not take. And this assures us some level of integrity for the database so that we don't put garbage in, because then we'll get garbage out. So this is another table where we see physicians. So each physician has a number, and then of course they have their specialty phone, whether they have certain privileges or not. Okay, so in this case, the primary key is their physician number right here. 123 is for John Smith, 345 is for Mina Sherry, and so on. Now, what we have done is we have combined those two tables into one. So let me go back quickly. So we had the patient table first. Okay, so we have each patient with a particular number. This is the primary key, by the way, this one that's highlighted in blue. That's the primary key for this table. And then we also have the physician table. They have their own primary keys right here. So imagine if we have a patient that comes back to the hospital again. So let's say we have this patient with number 86175. 86175 appears twice. This means this patient with this medical record number was admitted twice in the hospital. We can go back. The value of having this type of, let me go back to the table one more time here. So again, it's 86175. Let's look it up here. 86175 is Nora Miller. Okay. Now, of course, if we're doing this in real life, we don't have to go back from table to table. Once you put in the number, you're going to actually be able to associate it with Nora Miller. The same thing, once you put the physician number, then you will know who was the physician for that particular admission. So in this case, the medical record number became a foreign key. In this case, it's no longer a primary key. What is the primary key in this table? Is the one that keeps changing. You see the billing number? So basically, the primary key cannot be repeated. Okay? In this case, the medical record number repeats because you could have the same patient coming back to the hospital multiple times. However, every time they come, they get a new bill. So the bill keeps changing. The billing number keeps changing. Okay? I hope this is making sense. So in this case, again, the primary key would be the billing number. So I'll show you another table here, another picture. So this is that patient table again, where we had that medical record number, last name, suffix, all of these things, right? And then on the right, we have the physician information that you already saw, all the way from physician number, the physician name, specialty, admitting privileges, all of that. So what we have done is we have combined these two. And all we need to do is we don't need to repeat all of this information every time Nora Miller comes back to the hospital. We can just drag this medical record number over here to the billing table, and then we can just update the admit date, the discharge date, the charges, and we can add the new information. And then also, at the same time, we can bring that physician number from here to here that's showing who took care of Nora Miller, for each admission. Okay? So again, the primary keys, you see the little key symbols here in both tables. They're brought here in the billing table, but this time they are serving as foreign keys, letting us basically just focus on that particular admission so we don't have to redo or re-register everything from the beginning every time the patient comes back. And this, by the way, makes the information and the data that we enter much better and higher quality, because rather than updating the information on multiple accounts, you update it in one place and then it's all done. Okay, so if the patient, let's say, changed the last name, then you update it in the patient table, and then it's going to be in every place. Every time they come back, that information is there already. Okay, I hope this is making sense. But again, review your information in the textbook. A little more on databases. Some terms that you might see out there are data models, which are the entities. What information will be collected on what? For example, if we're collecting information on a disease, what exactly are we collecting about it? Is it just the diagnosis code? Is it the symptoms, treatment? What is it? Data dictionaries. Data dictionaries outline the data elements like the name or medical record number, the type of data, the length edits. So for the first name, what is it? Is the first name of the patient. This is going to be alpha or letters. That's the type of data. How long is it going to be? Let's say we'll give it 25 characters just to make sure that all is going to fit in there. Or the name of the data is gender. For this one, it's still going to be letters, but the length is going to be just one character, and so on. Okay? And edits allow you to avoid entering certain things that are not going to be correct. Okay? So, again, we had the example of male, female, and how you could not enter anything else but M, F, or U. Database integrity has to do with making sure that we're not repeating information, thus increasing the chance of error, and then putting certain constraints in place and making sure that the information is accurate. So, another example of a constraint, we obviously talked about the M, F, or U for male, female, or undetermined, but think about temperature, recording the temperature for the patient. And let's say that the temperature um, max in Celsius, degrees Celsius, can't go higher than 45 degrees. Otherwise, it just doesn't make sense. It can't be for a live person to have, let's say, 50 degrees Celsius temperature. Okay, so an integrity constraint would be that you can't by mistake record, let's say, 42, by mistake record 52, or um, even transpose the digits like 25 or something like that, because that would be too low. So the integrity constraints would be, let's say, anywhere from maybe 30 degrees to 45 or 46 for that for the patient's fever or temperature. Database management systems, these are computer programs that manage databases. Okay, how they're used, how they're created, how they're maintained. They can be personal if you have a number of databases in your computer, and you could use a database management system, but they're typical for workplaces and they're server based over there. Data warehouses, these are databases of databases, so very large virtual space of databases. And then data repositories, these are smaller, they're typical for a hospital though. Data mining has to do with searching or digging through the data to find patterns or relationships. Okay, let's talk about telecommunication. Telecommunication has to do with the way we communicate the information to our computers, to our uh, uh, vendors, and other parties. And how does that happen? It happens in different ways. The typical way to communicate is to have a transmitter, a receiver, and the actual medium and data. So this shows you the communication, the phone communication, this example. All right? But in our network, we use the computers, the hardware, and then think of, let's say, the safe portals where the information go via the internet and be transferred, let's say, to a payer's website or an insurance website. So that's basically how the information would be sent or be received. Now, this is the foundation for health information exchange, which is basically the process of sharing information among different providers with the ultimate purpose of caring better for the patient and providing better continuity of care. Now, networks, of course, need computers, and in this case, they can be servers or clients. Servers are those computers that share resources. So if you go in a lab, you'll see the servers there, and basically it could be a printer, storage space. Let's say you save something, you go home, you don't have it with you because it was shared on a server at the school. Clients, they can access shared resources. So if you hook up your laptop or a PC to the server, then you can bring up applications you don't have on your own computer. These are typical in hospitals, by the way, where not everything is sitting or being stored in that particular PC. They're stored in servers, and they're associated with your profile, with your username. And these clients and servers are related to each other, and they do provide a variety of services, anywhere from applications to backup. Sometimes a computer can be both. It can be a server, it can be a client. It just depends on what functions they're going to use for that. So a little more on telecommunication. They have their own architecture as well. What is this? This is how the network is set up. Do you have a small area that needs to be connected? In that case, it would be a local area network, like just one building. Or do you have a wide area network? You have a hospital, you have another building with physicians' offices, and another one that has a home health agency in there, or maybe a rehab facility. Then maybe you're talking about a wide area network. Or you could have wireless networks, as we see mostly nowadays. There's network topologies, which has to do with how those computers are connected with each other, how the cable's wired, pretty much. And you're not going to do much with this information really, but just be aware that there can be different ways of connecting computers with each other, and the way they are connected, whether it's a bus shape or star shape, ring or mesh, and the pictures for these are in your textbook, then the speed of communication may vary, and the reliability. This one I want you to really pay attention to, the data transfer and the network protocols, especially health level 7. So what are protocols? These are basically, just as the name suggests, rules that enable computers to communicate with each other despite of their differences. So when you see, let's say, that HTTP on the web address, you're talking about having a network protocol, right? Health level 7 is a standard that is specific to healthcare. It develops standards for healthcare organizations. So if you run into this type of question, please don't forget that. So HL7 associated with a standard, and it is for healthcare, so that we can all communicate the information in a certain way. I'm going to make a gross analogy here. So when you buy electric outlets and you plug it into your wall, then they're going to work no matter what made they are and what type they are. They're going to connect to that a source of power, electricity, right? So that's what we want to make sure. If you get labs from any facility, we're going to be able to understand them. Or if you get radiology images from any place, you're going to be able to understand them. That's what these standards are about. And of course, there is more to them in terms of the medical terminologies that are used, and the descriptions of diseases and so on. So we have seen much growth in our use of internet in healthcare. We see it um, in terms of patient portals or paying your bills electronically. We also see the claim submissions from the hospital to the insurance company, or electronic prescriptions sent directly to the pharmacy. So lots of growth in the last 10, 20 years in this direction. So a little bit more here. What do we talk about? Why do we talk about management when we talk about information systems? Because information is a resource. Okay. Obviously, it helps us make decisions, and it helps us take care of the patients, um, schedule our employees better, manage our inventory. So, of course, we need to manage it. For this reason, there's different levels of management. There is strategic planning, or a chief information officer. There is management of the technical infrastructure and staff, which is the information systems, or the IT usually, or IS. Management of security and privacy, that would be typically a chief security officer or a chief privacy officer. And then, of course, we have management of health information in terms of data collection for patients, storage, coding, medical coding, and that would be the health information department, the coders, health information technicians, health information management professionals. What are some examples of productivity software? We have database systems, we have spreadsheets, presentation software, such as this one I'm using now, project management software, groupware, Groupware is WebEx, again, the one I'm using now. So here's an example of a database example, right? So it's access for anybody that has ever used it. This is how it looks. This is an example of a project management software. Basically, you put what needs to be accomplished and how long is it going to take, when should it start, when should it end, who is responsible for it. All right? What are some other EHR related concepts? Paper versus hybrid versus electronic. So just make sure you understand the difference. Paper is just paper. Hybrid includes some electronic, some paper, and electronic is straight electronic. You just make sure that you know how processes need to be specified in one way or another. Safeguards, it doesn't matter, you still have to treat all the information equally. The inventory and the definitions, just knowing where each type of information is. If you have hybrid, especially, that becomes even more complicated. Okay. Electronic document management system, that's usually used when we're in transition and are scanning a lot of records and just making them available online, but we can't say that it's totally electronic. Electronic is when everything is being entered directly in the computer. It's not written or handwritten in paper first and then scanned. Okay. The other part is backup and continuous operations to avoid downtime and data loss. This comes up. You probably see things like that in the news or maybe in your workplace. So just making sure that you're not losing the data. Then what is suggested is mirrored processing and redundant servers, which means all the information that's being entered is being entered automatically into two servers or three, so that if one goes down, you still have it in the other. Making sure that the vocabularies that are used are consistent. So when you use a certain code, a medical code, you know that that represents that particular disease, as in ICD-10. Or when you use a certain abbreviation or code for prescriptions, it's part of that RX norm. Or something for the labs again, and it's going to be consistent everywhere so that you can communicate that information and understand the information that comes from other places. And then one more time, there are standards that we use to ensure that the information we send and we retrieve is understood. And that's very critical in data exchange. And the health level 7 is number one. Then there is DICOM for digital images. ANSI is another standard setting organization or agency. When we talk about the acquisition of EHRs, I want you to review sales pages 1003 to 1009. There is some figures there as well. And just focus on what readiness is, planning, selection of the system, the implementation. And when it comes to that, pay attention to the testing and the data conversion, which we already mentioned, maintenance and improvement. And then also be mindful that sometimes there are even questions about change management and the challenges that arise during the implementation of new systems or electronic health records. So another part of this domain is statistics. And there is a whole course that you do for this, HIT 226. Hopefully the information you have received there is still staying with you. And in this lecture, I'm not going to solve problems for you, but I'll show you a couple of things and just tell you where to focus on. Make sure you know the difference between individual versus aggregate data. This was reviewed in week 2 lecture. The difference between inpatient and outpatients. Inpatients hospital, outpatients are in ambulatory care. It makes a difference when you do calculations, that's why. Tables and graphs were also reviewed earlier, how they're used and how to understand the information. There is length of stay, how long a patient is staying in the hospital, and then average length of stay. On average, how long do the patients stay in a hospital? There is the concept of mean or average, median, which is the middle number, or mode, which is the number that repeats the most. There is tons of information on death rates and autopsy rates. Okay, so I need you to review those formula that are there and make sure that you know how to solve some of the problems. Here is one quick problem. We have our patient population. Let's say we have 6 patients, and their length of stay is recorded. Let's say for patient 1, 4 days, for patient 2, 2 days, and so on. How can we calculate the mean here? So basically, you add up all of the length of stays, 4 plus 2 plus 6 plus 3 plus 2 plus 1, and then you divide it by the number of patients you have. In this case, we have 6 patients, so that is divided by 6, and it gives us 18 divided by 6 is 3. So you would say the average length of stay, or the mean, is 3 days. What is the mode? Mode is the number that repeats the most. In this case, because you have a short table, I mean, you only have 6 patients, you can quickly see 2 is the one that repeats the most, and you can say 2. In case no number repeats at all, then there is no mode. It's okay to have no mode, okay? Or sometimes you can have multiple modes. You could have two patients that stayed 2 days and another 2 patients that stayed 3 days, and that would mean that the mode is 2 and 3. Median, on the other side, requires that you order these numbers from the smallest to the largest. So you start with 1, 2, 3. Actually, I missed a 2. So 1, 2, 2, 3, 4, 6. So right here you have 1, 2, 2, 3, 4, 6. Then you take the middle numbers, you would add them up and divide by 2. So 2 plus 3 divided by 2, that gives us 2.5. If we only had 5 patients and they had length of stays that were 1, 2, 3, 4, and 6, then the median would be the middle number. No need to add and divide. Calculating death rates. So this is another example that shows you how to calculate death rates. You basically are given this information. You're to calculate the newborn mortality and fetal death rates. First of all, you need to make sure you know the formula and the definitions. What is considered a newborn, okay, and then what is considered a fetal death. So you would find, first of all, for the newborn death rate, you'd multiply the 3 newborn deaths. So you look here, newborn deaths, there's only 3. And then you multiply by 100, and then you divide by the number of newborn discharges. Basically, it's actual versus potential. So how many actually died? 3. How many did we have altogether? We had 248. So potentially, all 248 could have died. However, only 3 did. So 3 times 100 divided by 248 gives us 1.21 mortality rate. Keep in mind, your mortality rates will always be low. We have low mortality rates. So look for them in the single digits typically, okay? And do show the decimal numbers after. Sometimes you're asked to calculate the fetal death rate. So what is a fetal death? What is considered fetal death? Only the intermediate and late fetal death, so not the early ones. You have them in the table, but you're not going to do anything with it. So just the 3 intermediate plus 1 late death, and then those two multiplied by 100. And then you're going to go into the live births. So how many live births did we have? 245. And then add those that could have been born alive, but they didn't. So the 3 plus 1, because again, it's actual versus potential. The actual was 4. The potential is the 245 that were born alive, luckily, and then the plus the 3 and plus the 1 that were fetal deaths. Okay, so this would give us 400 divided by 249, and it's 1.61%. Autopsy rates, basically these numbers are going to be a little larger because you're going to compare those that were autopsied on versus those that died. So the number of deaths is usually low, but the number of autopsies is usually low as well. But when you compare, let's say, 8 deaths with 4 autopsies, then the rate there is going to be pretty high. Okay? Sometimes it is, sometimes it's not. It depends, but these could be larger than the death rates. That's what I'm trying to say. So I want you to pay attention to this slide and look at the different calculations for gross autopsy rate, for net autopsy rate, adjusted hospital autopsy rate, and so on. And then please use your book for the formulas as well and take some time to practice with these. So, what are some important takeaways? Please read your chapters. Try to read a little bit every night so that you know what each chapter has. Also, review all the material carefully. Whatever is in that sales textbook does matter, and Horton as well. And then, if it helps, make some flashcards, underline or highlight, and then practice with questions. There is a book called Professional Review Guide for the RHIA and RHIT examinations. So that is really a great source for practice. I hope this lecture was helpful, and if you have any questions, feel free to reach out to me. Have a great day.